Welcome back to our RP. Today we are going to continue with the word problems involving maxima and minima. You have to find a point on the curve y square equal to 4x which is nearest to 2, 1. See, y square equal to 4x, you know, is a parabola. So it's a parabola like that, okay? And then you have a point 2, 1. So you have to take any point, let me take any point x, y on the parabola and assume that it is nearest to 2.1. And then we will find out what sort of point it is. So let x, find a point on the curve whose distance from the point 2, 1 is minimum. Nearest means what? Minimum distance. So let x, y be a point on y square equal to 4x which is nearest to 2, 1. Okay. Then what will be the distance? D square. Okay. Which let me call it as say f will be x minus 2 the whole square plus y minus 1 the whole square. I am using distance formula. X minus 2 the whole square plus y minus 1 the whole square. We have to find minimum f. Okay. So there are infinitely many points on the parabola. We want to find that point on the parabola y square equal to 4x which is closest to, nearest to, which is at a minimum distance from 2, 1. Now this is a function of two variables, x and y are both variables. So how will I write one in terms of the other? We know that x, y lies on y square equal to 4x. Okay, so I can write y as 2 root x, or I can write x in terms of y as x equal to y square by 4. Okay, so I'm going to replace, now this is a function of two variables x and y. I want to express it as a function of a single variable y. So I'm going to write f as, okay, what is x? Y square by 4. So y square by 4 minus 2 the whole square plus y minus 1 the whole square. Okay, now df by dy will be 2 into y square by 4 minus 2 into derivative of y square by 4 which is 2y by 4. Okay. See, I am differentiating 2 into y square by 4 minus 2 into derivative of what is within the bracket. The derivative of what is within the bracket is 2y by 4 because the derivative of minus 2 is 0 plus 2 into y minus 1. Now df by dy equal to 0 for finding the critical point. Okay. Therefore, let me first simplify this. So first, this is 2, y by 2. So 2 into y square by 4 into y by 2 minus 2 into 2, 4, 4y by 2 minus 4y by 2 plus 2y minus 2 equal to 0. Minus 4y by 2 is minus 2y. So minus 2y and plus 2y gets cancelled. Now from here it is y cube. Okay. 2 gets cancelled. So y cube by 4 minus 2 equal to 0. So y cube equal to 8. Y will be what? 2. If y cube is 8, right? Y cube equal to, see, y cube minus 4 by minus 2 is 0. So y cube is equal to 8. So y equal to 2. So if y is 2, what is x? We know that x is y square by 2. Here we have written what is x in terms of y. So x is equal to y square 4 by 4, which is 1. So the point is 1 comma 2. So we now claim that 1 comma 2 is the nearest point. But how will you be sure? I have to find the second derivative. What is d square y by dx square? D square y by d square f by dy square. D square f by dy square will be, okay, I have to differentiate this equation, right? So when I differentiate this is what I've equated to 0. Otherwise, it is this 2. Otherwise, it is 2 y cube by 8. So y cube by 4 minus 2 is the first derivative. It is df by dy is equal to y cube by 4 minus 2, because these two gets cancelled. So when I differentiate this, I will get 3y square by 4, which is greater than 0. Or you, in fact, you can substitute for 2. It is actually 3 into 2 square by 4. It is 3 equal to 3. Therefore, the distance f, which is equal to d square, is minimum at 1 comma 2. So the minimum distance is from the point 1 comma 2. So the distance from 1 comma 2 to 2 comma 1 is the minimum distance. The point 1 comma 2 on the parabola y square equal to 4x is closest to, nearest to, is at a minimum distance from 2 comma 1. Is it clear? I've expressed x in terms of y because it is much easier to make the calculations easier. But you can also write y in terms of x. Look at the next problem. An helicopter, I'm just combining problems of similar type. An helicopter is flying along the curve y equal to x square plus 7. This is again a parabola. A soldier is placed at 3 comma 7. Want to shoot down the enemy helicopter when it is nearest to him. So you have to find the nearest distance. Okay. So let x comma y be a point on y equal to x square plus 7, which is nearest or closest to 3 comma 7. Okay, then what will be the d square, which I'm going to call as f. If d is maximum, d square is also maximum or minimum. If d is minimum, d square is minimum. So d square I'm calling as f will be x minus 3 the whole square plus y minus 7 the whole square. Distance between x comma y and 3 comma 7, x minus 3 the whole square plus y minus 7 the whole square. Now I can write y, this is a function of x and y are both variables. Because at any point, we are of all the infinitely many points on the parabola, we are finding that point which is closest to 3 comma 7, which is what we are assuming as x and y. So x and y are variables, but we know that x comma y lies on this. So y is equal to x square plus 7. So f is equal to x minus 3 the whole square plus x square plus 7 minus 7 the whole square. This is x square minus 6x plus 9, right? Plus, this is what? 7 gets cancelled. Y is x square. So, x square, the whole square, which is x power 4. So, f of x is x power 4 plus x square minus 6x plus 9. Now what will be df? To find the critical point, find df by dx, which is 4x cube plus 2x minus 6. Okay. Now to find the critical point, df by dx is equal to 0. Therefore, 4x cube plus 2x minus 6 equal to 0. That is x cube, 2x cube plus x minus 3 equal to 0. If I put x equal to 1, I know that it is a factor. If I put x equal to 1, 2 plus 1 minus 3 equal to 0. Therefore, x minus 1 is a factor. That means, therefore, x is equal to 1. When x is 1, what is y? 8. Using y is x square plus 7. So when x is 1, y is 8. Is this the point which is closest to 3, 7? How can we check? We have to look at d square f by dx square. Will be 6x square plus 1. When x is 1, d square f by dx square will be what? 7, which is greater than 0. Therefore, f is minimum at x equal to 1. So, which is the point which is closest? When x is 1, what is y? Y is 8. Therefore, conclusion. One comma 8 is nearest to 3 comma 7. What is the distance? They have asked you to find the nearest distance. So distance will be root of 3 minus 1 the whole square, which is 4, plus 8 minus 7 the whole square, which is 1, which is root 5. Root of x2 minus x1. So 3 minus 1 the whole square, which is 4. 2 square, which is 4. Plus 7 minus 8 is minus 1 square, which is 1. So root of d is root of 5. So the minimum distance is root 5 units. Is it clear? This is also similar to the previous sum, but based on a particular life situation. Is it clear? Next problem. Prove that the area of a right angled triangle inscribed in a circle is maximum when the triangle is isosceles. So what is given? So you have a circle in which you have inscribed a right angle triangle. Let ABC be a right angle triangle. Okay, which is inscribed in a circle. You have to prove that it is of all the right angle triangles that you can inscribe in the circle, because I can draw infinitely many, right? If with this as a diameter, if I draw any triangle, it is going to be a right angle triangle, because angle in a semicircle is 90. Okay, of all the right angle triangles, you have to prove that the one which has got maximum area is isosceles. Okay. So let ABC be a right angle triangle of maximum area inscribed in a circle. Okay, so what is the what is it that you have to maximize? The area. Area equal to, okay, let me call this as A and this as B. So right angle triangle, so half A, B. Both A and B are variables because I've already told you, you can draw infinitely many such right angle triangles. So I have to express one in terms of the other. But I know that AC square of a right angle triangle would be maximum when the triangle is isosceles. So if this is right angle, I know that AC square, which is, let me call it as, say, this is C and C, okay. 4C square is equal to A square plus B square. Now 4C is fixed because inscribed in a given circle. The circle is given, inscribed in a circle means the circle is fixed. Circle is fixed. So its radius is a constant. Therefore, C is a constant. Therefore, C is a constant. Now, area will be small a, I'll write because I want to square it. 1 by 4 a square b square. This is 1 by 4 a square into, what is b square? 4c square minus a square. 4c square minus a square. Again I am writing A and B are variables because you can have infinitely many such triangles. We are looking for that one which is going to give you maximum area and prove that it is an isosceles triangle. Okay, so this is A equal to A square by 4, or I can simplify this. 4 into 4 will get cancelled. A square, since I have already used A, I will use K. K equal to 4 and 4 gets cancelled. A square C square minus A power 4 by 4. A square C square minus A power 4 by 4. Now A is a variable, C is a constant. So dk by dA will be C square into 2A minus 4A cube by 4. Equate it to 0 to find the critical point. So 2AC square will be equal to A cube. Cancelling off one A, 2C square equal to A square, or A is equal to root 2C. If A is root 2C, what will be B? We know the relationship between A and B. The relationship between A and B is given by this. Right? If A equal to root 2C, B square equal to 4C square minus A square, which is 4C square minus 2. When I square this, what will I get? 2C square, which is 2C square. So B is also root 2C. So A equal to B, therefore the triangle is isosceles. So when the area is maximum, the triangle is isosceles. We have only checked the critical point. The critical point is A equal to root 2C. And we have checked that at that critical point, area is, B is also equal to A. So the triangle is isosceles. What is the confirmation test? You have to do d square k by dA square. That will be, when I differentiate this with respect to A, I will get 2C square minus, this will be what? This is when I differentiate, This is I get 4a cube by 4, only a cube is there. So minus 3a square. What is 2c square in terms of a square? You know that a is root 2c. So c is equal to a by root 2. Right? So c square will be a square by 2. 2 into a square by 2 minus 3a square. A square minus 3a square is minus 2a square, which is less than 0. Therefore, conclusion, area is maximum at a equal to root 2c. Is it clear? So today we discussed three word problems based on maxima and minima. So if you go through all the videos, there are several videos where the focus is only on word problems involving maxima, minima being a very important concept. I hope you would find these videos useful. If you do not forget to share it with your friends, and please practice these problems with understanding. Then you will be able to solve any problem in maxima, minima. So until next time, it's goodbye. All the very best for every one of you.